As we are speaking, the Euclid Telescope is being prepped to be launched on a Falcon 9 in July 2023. Euclid is a telescope that is being made by the European Space Agency, ESA, and a group called the Euclid Consortium. The goal of this telescope is to help us understand two mysterious things called dark energy and dark matter. Since scientists and researchers were curious about these two beauties, they wanted to figure this out with the Euclid. Euclid will look at the shapes of galaxies at different distances from Earth and see how they change over time. This will not only help scientists but us to learn more about dark energy and how it affects our universe's expansion. Here are the 5 mysteries that ESA researchers hope to solve with this telescope. 1. What is the structure and history of the cosmic web? Our universe is made up of a massive structure called the cosmic web. It's like a network of huge clusters of galaxies connected by invisible dark matter and gas. There are also big empty spaces called cosmic voids in between. It's hard to study the cosmic web since it's so massive, with some empty areas being hundreds of millions of light-years wide. This Euclid project will help us explore back in time by observing the light from stars that have taken billions of years to reach us. By mapping out the shapes, sizes, and positions of many galaxies, Euclid will reveal the structure and history of the cosmic web. Even though we can't see dark matter, it affects the light of distant galaxies, and Euclid can use this effect to our advantage by observing how dark matter is distributed in the universe. 2. What is the nature of dark matter? Scientists still don't know what dark matter is made of, but they assume it's mostly heavy and slow-moving. However, some dark matter might be made of lightweight and fast-moving particles called hot, dark matter. These particles, called neutrinos, barely interact with other matter and have a very small mass. Euclid can help us figure out how much of dark matter is made up of neutrinos and how it affects the formation of cosmic structure. But there's a chance that Euclid could discover new, unexpected particles that make up dark matter. In short, Euclid is like a detective searching for clues in our mysterious dark universe. 3. How has the expansion of the universe changed over time? In early 1990s, scientists found out that our universe is expanding faster than it is supposed to be. They thought it would slow down over time, but it's actually speeding up. To understand this, scientists use standard candles, which are objects with a known and consistent brightness, to measure the expansion rate. They compare the brightness and color of these objects to determine their distance from us. The Euclid will also measure the redshift of galaxies to determine their distance from us. This is important because it helps scientists understand how the expansion rate of the universe has changed over time. Furthermore, Euclid will investigate whether the expansion is the same in all directions. If it's not, it would be a violation of the cosmological principle, where we have to rewrite all our science books, which states that our universe looks the same in all directions and from every location. Understanding the acceleration of our universe's expansion and whether it's the same in all directions is very crucial for our understanding of the universe and its history. 4. What is the nature of dark energy? As the cosmologists have observed that the expansion of our universe is not slowing down, but rather it is accelerating. To account for this accelerating expansion, they have proposed the existence of a mysterious and unknown component of the universe that they call dark energy. The nature of dark energy is not yet understood, but the leading hypothesis is the cosmological constant, first proposed by Albert Einstein in 1917. This suggests that dark energy is a constant energy field that exists throughout the entire universe. It is an intrinsic property of space itself, meaning the more space there is, the more dark energy is present and the stronger its effects. While there are other concepts like quintessence, suggesting that the acceleration could be caused by a fifth fundamental force of nature that changes over time as the universe expands. There are multiple different hypotheses about the nature of dark energy. Scientists have not yet been able to gather enough evidence to support one idea over the others. 5. Is our understanding of gravity complete? Dark matter and the accelerating expansion of the universe suggested us that there's definitely something missing in our understanding of gravity. So far as we understood, gravity is what keeps planets, stars, solar systems, and even galaxies together. Albert Einstein's theory of general relativity is the best explanation we have for how gravity works. It suggests that gravity is not a force of attraction but is caused by massive objects bending space and time, like a heavy ball on a trampoline. General relativity also predicts the existence of black holes in gravitational waves, time passing faster or slower for different observers, and light being affected by gravity. Although all these predictions have been proven correct, no test has been done on a large enough scale to prove general relativity's accuracy over large distances and times. But our Euclid will test this theory with high precision, revealing if general relativity works at the largest scales. Sadly, if it doesn't, our physicists will need to develop new theories. Overall, let's just hope for Euclid's telescope to be launched into space in July 2023 successfully. It will travel for 30 days to a spot called L2, where it will stay for at least 6 years. Euclid will take extra observations of 3 smaller areas in the sky. These extra observations will help scientists check if the telescope is working well and collect more information about the farthest galaxies and quasars in our universe.